We have an incredibly long tradition of excellence and achievement. King's dates back to 1829, and since that time, we've had some of the most outstanding people working here. Back then, we had people like James Clerk Maxwell, who I'm sure many of you will know. Does anyone? Can't see any nods at all. James Clerk Maxwell, who developed his famous equations of electricity and magnetism. Fundamental work on electricity. Absolutely critical to everything that we do today. But even more recently, so only just 3 years ago, of the 5 Nobel Prizes that are awarded, 2 of the winners for chemistry and for physics were King's graduates. They studied here at King's, okay, which is a phenomenal achievement as well.
We do have, as humans, we do have some limitations. So we do get tired, especially if we've had a hard day at work. And we have emotions, and emotions can influence the decisions that we make, and sometimes in a bit of a negative way. Although we do have wonderful senses and motor skills, doing very fine movements is very difficult. So I'm sure some of you will have tried threading a needle, that can be quite frustrating to do. And of course, when we are working as a team or trying to work as a team, we argue, and we don't always easily reach a consensus or a joint decision. And although our brains are wonderful, we do have limited computational abilities. We can't do mathematical sums in the same way that a computer can. So that means in the medical domain, we have the possibility of making mistakes, and those mistakes can be quite serious because we're dealing with human beings and human beings' well-being and lives. The other problems we're facing in healthcare is that we've got limited amount of money to deliver healthcare, and we have limited staff, and therefore we are being pushed to make our healthcare systems more efficient. And that's where machines come in, and robots, because robots are a potential solution for providing better healthcare and more efficient healthcare.
Synthetic chemistry. So I'm a synthetic organic chemist, and what I'd like to do is make molecules, as Jess mentioned. So one of the areas my group's works in is making these synthetic peptides. The idea is that we can eventually disrupt protein-protein interactions. And in order to do that, we need to start making some synthetic molecules, so unnatural amino acids. So we need to develop synthetic chemistry to be able to do that. And one of the amino acids that we're interested in is this cyclic amino acid. It's called a beta amino acid because it has one more carbon between the nitrogen and the carbon here than a normal alpha amino acid. And what's known is that if you incorporate these types of amino acid into a structure which also has alpha amino acids within it, then you can actually still obtain a really stable secondary structure in the form of a helix in this case. And what's really interesting about this is the side chains that are on these alpha amino acids are displayed around the helix in a very specific way. So if you know what that specific way is, then you're some way towards understanding which proteins and peptides you're able to mimic in terms of preventing these protein-protein interactions from happening.
What do we do in visual computing? Well, our aim is to extract the meaningful information from data streams, data warehouses, anything that holds more than just numbers, and find out the really critical and most important aspects of a set of data, and try to convert it into something that is usable and enjoyable and can really have an impact on everybody who is going to use those particular pieces of information. This can take several aspects. My main focus is scientific fields, more information-related fields, and I've also worked a bit in digital humanities. From your side, probably you have been in touch with data visualization in terms of entertainment. You can think about 3D cinema to video game, and that is more like more graphics-related applications, to anything which is related to augmented reality, or even your apps on your phone.
The term fractal comes from the Latin fractus, meaning broken, but the term was coined by Mandelbrot in 1975. So quite recent. I quite often give talks on mathematics where I'm referring only to mathematics that was invented before 1900. So this feels very modern to me today. So what is a fractal? Well, it's a bit hard to explain, really, but what I can do is I can give you some characteristics of fractals. So one of the most important characteristics of a fractal, a snowflake, is that it is self-similar. So you will all have remembered from school the idea of similar triangles. Two triangles are similar if they have the same set of angles. So one is a baby version of the other, or one is a big version of the other. So that's the notion of similarity, the same shape but possibly a different size. The idea of self-similarity is that the object is in some, if I take a small piece of the object and I magnify it a lot, then it looks like either the object I started with or at least part of it. So it's similar to a part or maybe the whole of the object that I started. So that's the first characteristic. The second, and this is very important, is a notion of roughness. Much of the mathematics up until, say, 1900, so all but the last 100 years, has been very much concerned with smoothness, with smooth functions, with smooth curves. Fractals turns that on its head and said, no, we're going to look at things which are rough, which are very rough, which have lots of spikes and corners.
The thing is, though, if a supernova had gone off in our galaxy around the time of Jesus, there were so many people around who had their heads screwed on, there would be more records of it. So it would have been so bright that everybody would have gone, my goodness me, look at that in the sky. Everybody would have noticed it. Even punters, not just wise men, people like us would have gone outside and gone, my God, there's a massively bright star in the sky. And we'd know about that. And there aren't records of that around the time Jesus was born. So what we need is some star that appeared in the sky that if you were an astronomer, you would notice. But if you were just a punter, somebody like you or me who didn't have a telescope or whatever, I haven't got time to be really on top of these things, we wouldn't notice, okay? Now, so some people have got this idea. It's what I'm going to talk about today. In particular is this guy, Frank Tipper. He's got this idea. Was Jesus born March 22nd, 8 BC? So why 8 BC? Well, because there was a census 8 BC. There was no census at 0 BC. And people are fairly sure that we've got the date wrong when Jesus was born, okay? I mean, Jesus definitely existed. There's no question of that. But we don't know precisely when he was born. So maybe it was 8 BC. Also, a lot of Ptolemy learned all of his astronomy from the Babylonians, okay? Quite a lot of it. And he made good records of his theories. So, for example, March the 22nd is the vernal equinox. So that's the time when you've got equal day and night everywhere on the world. And it's also associated with nativity. So if you were a Persian astronomer, you might have associated a new star which appeared at the vernal equinox with the birth of a king.